All right, guys, number 4, we're on the back side of day 10 notes, says that in triangle ABC, and we have no picture, so we're going to have to draw our own. I'm going to draw it big to make sure I can fit everything in there. It says that D is a point on AB. I'm not quite sure where to put it, but they didn't say it's a midpoint, so I'm going to go ahead and put it a little higher so I don't jinx myself or think that I have something that I don't. All right, so D is a point on AB, and then it says E is a point on AC, such that when I connect them, DE will be parallel to BC. So I'm trying to envision my parallel line here. So I'm going to go ahead and say that it's going to look something like that, maybe. And so I'm going to go ahead and drop my E right here so that it's on AC, so that this line here, DE, looks parallel to BC. And it says that AD is 2, and that DB is x minus 1, and that AE is x, and that EC is x plus 2. And so if we turn our picture, you might be able to see it a little bit better, but this is side splitter because that blue parallel line in there is splitting this side here and this side here into 2 pieces. And so side splitter says that we can use those individual pieces and that we don't have to separate our triangles if we want to make our problem easier. And so I'm going to go ahead and highlight my corresponding pieces there and there. And so now I'm ready to go ahead and set up my proportion or my fraction equal to my fraction. So I'm going to go ahead and choose 2 and put it over its corresponding side of x. And I'm going to put it equal to x minus 1 over its corresponding side of x plus 2. And now I'm ready to go ahead and cross multiply. We'll do this cross first. Be careful, it's x times x, which is x squared, and x times negative 1, which is negative x. And that's going to be equal to this cross here, which is 2 times x, which is 2x, and 2 times 2, which is positive 4. And again, we got that squared term, so we know we're going to have to factor, but we can't factor unless we're equal to 0. And I'm going to go ahead and subtract my 2x. And I'm going to go ahead and subtract my 4. And what I have left is an x squared. I have a negative x minus 2x, which is negative 3x, and then the minus 4 that I brought over, and we are equal to 0. And now I can set up my x box, my multiply at the top, which is negative 4, and my add at the bottom, which is negative 3. And if I go back to my multiply, the only 2 numbers that multiply to 4 are 1 and 4 and 2 and 2. And I know 2 and 2 can't give me 3, so I'm going to go with 1 and 4, or 4 and 1. And to get a negative 3 out of there, my 4 is going to have to be the negative 1. So if I check my numbers in the top and I multiply them, it works. And when I check them in the bottom, when I add them, I get negative 3, and so that works. And so I'm going to go right into my factors since it's what I call an easy trinomial. You can go right to your factors. That's why I call it easy. And once I have my factors, I'll do my t-chart. On this side, if x minus 4 equals 0, x will equal positive 4. And on this side, if x plus 1 equals 0, I subtract 1, and x comes out to equal negative 1. Again, 2 answers is fine in math. However, in geometry, when we have pictures of line segments or angles that can't be negative, most likely the negative 1 will go away or get rejected. And we can see that it is going to get rejected right there. That side, AE, cannot have a length of negative 1. And now I have a reason to reject it. And we'll keep x equals 4 as our value of x. However, they want to know the length of AE, but AE is x. And so now we can go ahead and say that AE equals 4. All right, let's take a look at number 5. It says to find the distance across a pond from point B to point C. A surveyor drew the diagram below. The measurements he made are indicated on his diagram. Use the surveyor's information to determine and state the distance from point B to point C. So this is what we're figuring out. So we'll put our x there. Okay, to the nearest yard. So it might look like we got some rounding to do at the end. All right, so didn't say anything about midpoints. Otherwise, I would know the value of x right away. If D and E were midpoints, it would just be twice as much as 120, which is 240. This is not side splitter because that parallel line, DE, is splitting this side, and we don't have this side, so no side splitter. And instead, when we know that it's not side splitter, we know that we have to separate our triangles to see our sides of our triangles a little bit better. So I'm going to go ahead and highlight my one triangle. And I'm going to go ahead and redraw it over here. And in that triangle, I have 120 on this side, and I have 230 on this side. In my second triangle, which is the larger one, we'll go ahead and redraw it. And in this triangle, I have x here, which is what I'm solving for. And I got to do a little math in order to figure out this entire length here. 230 and 85 together. 230 and 85 together make 315. And so 315 is going to go in my picture. And now I have my 4 pieces. So I can go ahead and set up my proportion. All right, and so we're going to go ahead and say 120 over the corresponding side of x is equal to 230 over the corresponding side of 315. We'll go ahead and cross multiply, and I end up with 230x equal to 120 times 315, which is 37,800. Okay. Go ahead and divide both sides by 230. And we end up with x equaling, and it is a decimal, so 164.347 ... does keep going. However, they want to the nearest yard, and so that would be this spot here, the 4, but we'll have to look next door to see if it's 5 or higher to round it up, and it's not. And so we'll go ahead and say that x equals 164, and I believe these are yards, and we're finished. All right, we got one last one, number 6. It says in the accompany diagram of equilateral triangle ABC. So that seems like a big clue right there, equilateral triangle. DE is 5. DE is parallel to AB. And it says if AB is 3 times as long as DE. If AB is 3 times as long as DE, but they just told me DE is 5. And so 3 times 5 is 15. So on AB, I'm going to go ahead and put a 15. What is the perimeter of quadrilateral ABED? ABED. ABED. Well, we can't find the perimeter yet because we only have 2 out of the 4 sides. So we're going to have to think back to maybe that clue about the equilateral triangle. Equilateral triangle ABC. So this blue triangle is equilateral. And since I already know one side is 15, that must mean this side is 15 and that this side is 15. Okay. So the little triangle on top has a side of 5, and the big triangle has sides of 15. And they told me that DE is parallel to AB, which makes these angles equal, and then obviously angle C is a shared angle. So these triangles are similar. And if they're similar, then there's a scale factor. And in this one, our scale factor, depending on what triangle you're starting at and going to, easiest way to think is that scale factor is being multiplied by 3, or 1/3 if you're going from big triangle to small triangle. And therefore, I guess you can also think of it as if the big triangle has 3 equal sides, the small triangle is going to have 3 equal sides in order to keep them similar, right? And so the little triangle is going to have 3 5s, right? In order for the scale factor to work on all the sides. And so if this is 5, then I figured out that this has to be 10, right? 5 plus 10 is 15 for the whole side. And same thing on this side. And so now we can go back to that quadrilateral and figure out its perimeter. And so this quadrilateral on the bottom would have four sides, one of them being 10, one of them being 5, another one being 10, and another one being 15. And so now we can go ahead and say that the perimeter is equal to 40. And we answered our question. All right, hopefully that helps, and I'll see you guys in the next unit.